Hi, it's Whitney from the 3D Printing Today podcast, also known as Shapespeare on the Thingiverse. And this is Cells Bowl by Dizingof, which is one of the most incredible 3D printable objects I've ever seen. And I'm going to show you today how to make your own version of it, how to make things like it using relatively simple techniques. If you haven't already seen my video on voronis, you probably want to watch that first because we're going to be using a lot of those same techniques. Let's start by putting in a sphere, assuming we want to make a spherical bowl. You can make things pretty much of any shape, but a sphere works well. UV sphere. There we go. Now you can see we have a fairly coarse sphere here, and that's going to work well in this circumstance. If you've seen my other video on voronis, you'll remember that a voroni has two parts, two things that go into the algorithm. The first one is the mesh that you're performing the operation on, which in this case we're going to make this into a bowl shape. And the second part of it is the point cloud, which actually creates the seeds for the voronoi cells. So in this case, let's turn on edit mode here and go into wireframe mode so we can see all the way through the object. Let's deselect everything. And in order to make this a bowl, kind of like the cells bowl, we'll hit B for box select and then select the top and delete it. Okay. Now we also want to make the bottom of it flat so it'll stand up, not roll around. So we will select, again, box select and scale Z 0, and that'll make a nice little flat spot there. I think we're going to want a bigger one than that. So select a little bit more, scale Z 0, there. And that gives us a nice little flat spot there. Okay, go back into object mode and just take a look at it and see. Okay, that's got nice proportions. So you could do this. It doesn't have to be a sphere. It could be a cone. It could be a cylinder. It could be any shape you want. Pretty much any mesh would work with this technique. This is just a simple one, and it works really well. Now, at this point, you have a non-manifold object might or might not work in your equation, and it wouldn't give us the effect we want because the cells bowl, you remember, it has two layers of voronoi. There's a layer on the outside that curves over the top and then goes down on the inside, and that's what makes it so magical. So to create that effect, we're going to go over and add a modifier to this sphere, and we're going to add solidify modifier, and we're going to jack the thickness up a little bit. That's a pretty good thickness, 0.1. Make sure fill rim is selected, and that's starting to look like, you know, an actual solid that we could print. Now you notice it has a lot of facets on it. It's fairly low mesh resolution. We don't really want to deal with that. We want higher resolution, so we're going to add a subdivision surface modifier after that. Remember, subdivision surface modifiers create lots and lots of vertices, so be careful how many times you iterate. Right now, you'll notice we have 5,000 polys. That's well within our range. We can do that easily, so we can click this up. We now have 23,000. We're still okay. Click it up again, and we have 92,000. That's probably the most polys I want to deal with and try and run a screen recorder at the same time. And you see we've also created this nice, beautifully smoothed, curvy bowl. So the sweet thing about Blender, of course, is that we don't have to commit these modifiers. We can just export this. And in this case, we'll go export. And I'm going to export as an OBJ here, and I'll tell you why in a minute. But we're basically going to export this form, and we'll call it bowl solid. Now, I tend to use STLs most of the time, but in this case, OBJs work better because now we're going to create a point cloud. And if you try and import a point cloud in STL format into MeshLab, it just doesn't work. But if you put it in OBJ format, a point cloud imports just fine. Okay, so using the same model that we've got here, we're going to delete our Catmull Clark. We don't need that anymore. And we're down to our subdivisions here. And depending on what we're trying to accomplish, how many holes we want to put in it, this might be too fine. We'll try it and see how it looks. It's going to give us a lot of holes because we've got a lot of vertices here. But let's go and uncheck fill rim here. So you see we've now got two separate layers. That's going to work fine for us. And I think at this point we actually do have to apply the modifier because we want to go in and edit the individual vertices, which generally can't go into edit mode. With most modifiers at least, they won't allow you to edit the mesh until you commit the modifier. So here we are in edit mode, and you will see we've got all these vertices to work with. Now, one of the things that's really cool about Cells Bowl is that the outer voronois and the inner voronois are not lined up. So when you look through from one hole, you see the webbing of the inner layer. So they're not looking straight through both holes. That's part of what makes it really cool. So in order to do that, if we go into front view and go into wireframe, you can notice that our holes here are completely lined up. And we don't want them lined up because this would be looking straight through it. So what we want to do here is if we go select any point on the inner ring here and go Control L to select linked, and then looking down on it, if we go rotate Z to rotate around the Z axis, and we will just turn it until those vertices are lined up so they're not, everything's not lined up straight through, but this vertex on the outside is offset from that vertex on the inside. Okay, now let's select all and hit delete, and delete only faces and edges. And that leaves us with a point cloud. Those points will become the seeds for our voronois. All right, so we will save this, export it as an OBJ, and then bring it into MeshLab, and we'll pick it up there. Okay, so now you can see we've imported both our master mesh and our point cloud for our seeds into MeshLab, and we're going to turn this into a Voronoi. Now, I'm not going to show all the steps of this because I've covered it in great detail in another video, so we're just going to skip to the end of the process here. Okay, so here, and you can see that we've created our double layer Voronoi bowl. Now we're going to export this as an STL and bring it back into Blender, and that's where we'll finish up the last little bits. And now that we're in Blender, the process of finishing this is the same as we did with our previous Voronoi models. We want to add a solidify modifier. And in this case, we want to thicken it till the outer wall and the inner wall almost touch. But you want to have a little bit of a gap between them. Just about like that. Because you want to have some space there so they print as separate objects, and it looks really cool. Okay, now you can see that our you can't really see through our holes didn't end up as big as we might want them to be, but that's okay. That'll get fixed when we smooth. If we increase our subdivisions, that looks pretty good. So we're doing a high degree of smoothing, and I think we will add a subdivision surface just to soften things up, smooth them out real nice. And I think that's pretty good. Now, of course, since this is Blender, and I've done a little bit of setup here ahead of time, we'll just do a quick render of it so you can see really nicely what it would look like. Now, I have actually printed this type of bowl successfully. It's a good test of retraction on your printer. Not the easiest thing to print, but it's an absolutely spectacular form once you're finished. So that's how you can make a double-walled voronoi bowl in the style of Dizingof's cells bowl. You can go in and play with the shape. You can make different meshes. You can play with the point cloud and seed it in different patterns. This one's very regular, but you can make them random. There's infinite variation, so I'm happy to share this technique with you, and I look forward to seeing what all of you come up with. Thanks for watching. Keep watching my YouTube channel and keep listening to 3D Printing Today podcast.